Hi, I'm Professor Geoff Currie from Sturt University, and I'm a member of the International Advisory Committee for the IUPESM World Congress. I'm thrilled to introduce you to Professor Simon Cherry, who is a distinguished professor in the Departments of Biomedical Engineering and the Department of Radiology at UC Davis. Simon is a leader and innovator in biomedical engineering and medical physics. Among his many accomplishments, he co-developed the Explorer, the world's first total body PET scanner, and developed the first proof-of-concept hybrid PET MRI system. Simon is an elected fellow of 6 professional societies and a member of the US National Academy of Engineering and National Academy of Inventors, which is pretty impressive. He has many international awards and has authored more than 300 peer-reviewed journals, review articles, book chapters in the field of biomedical engineering and imaging. He's also the lead author of the widely used, and I use it myself, textbook, Physics in Nuclear Medicine, and I'm looking forward to the next edition, which must be very, very close. And so it's exciting to have Professor Cherry as a marquee invited speaker at the World Congress in Adelaide later this year, 29th of September to 4th of October. So I might just jump into a few quick questions. Simon, could you provide us with a little more detail of your career experience, some of the highlights, and your specialty at the nexus between medical physics and biomedical engineering?
Yeah, so first, Geoff, thanks for the interview. It's nice to chat with you again. My background's in physics. As an undergraduate, I studied physics and astronomy at the University of London. And then I went on to do a Ph.D. also at the University of London at the Royal Marsden Hospital, which is where I first got exposed to medical imaging and specifically to nuclear medicine. And that became a lifelong passion. After my PhD, where I worked on a fairly novel PET scanner they were developing at the Royal Marsden Hospital, I moved to the University of California in Los Angeles for a postdoc position. And I was fortunate there to work with some of the real pioneers in PET imaging, Edward Hoffman, Michael Phelps, and others. It was a fantastic environment in which to do a postdoc. And so I spent a very happy 12 years at UCLA, eventually joined the faculty there as well, and then moved to UC Davis in 2001, which is where I currently am. And I'm in the Department of Biomedical Engineering, so I'm right at that interface of being trained as a medical physicist, working in a biomedical engineering department. And the focus of my work really is around developing new detectors and new systems for nuclear medicine, particularly positron emission tomography, and then novel ways to use them and to improve the methodology as well.
Awesome. That's great. Thanks for that. Maybe you can explain a little bit about what you'll be talking about at the World Congress later in the year.
Yeah, so the talk will focus mostly around this concept of total body positron emission tomography. And it's a project that we've been working on. We first started this about 20 years ago now, in 2005. And the idea was to build a medical imaging system, in this case a PET scanner, that could actually see the entire human body at once, which means that we can capture the kinetics of our radiopharmaceuticals as they move around the body across all the different tissues and organs. So that's pretty exciting. That's data that we've never been able to capture before. And with the advent of this technology, we brought it to fruition. We got our first scans in 2019, so we're now 6 years in to actually having a system that can do this. We're discovering lots of interesting things, lots of exciting data, and I hope I can convey that excitement to the audience of the Congress.
I'm sure you will. And I think you touched on the next question a little bit there, but why do you think your topic is particularly important or relevant to the field today? And what are the key takeaways delegates will gain?
Yeah, so I think it dovetails very well with what's emerging in medicine today, which is that we're gaining an understanding that many diseases and disorders involve the entire body, not just a single organ. So even things like Parkinson's disease and stroke and cardiovascular disease, things we often think about the being of the province of a single organ, actually involve the whole body. And if you think about the immune system, which is involved in just about everything, that of course is a systemic phenomenon as well. So having this tool that allows us to image the entire body for the first time, I think opens up many interesting possibilities for studying medical problems from a systems whole body perspective, also looking at organ-organ interactions. And I think from a research perspective, there's just enormous opportunities ahead, particularly if we can find ways to integrate this with other very powerful technologies like the omics technologies, which do deep phenotyping, but only from very limited spatial information. Whereas we have lots of spatial information, but we're only measuring a very small number of things at a time. And I think one of the big challenges is how we can integrate all of this to provide a better view of what's happening across the body.
So it's a pretty exciting future for the biomedical engineering and medical physics by the sounds of it.
I certainly think so, yes.
So what excites you most about presenting at the World Congress in 2025? And, what excites you about your upcoming trip to Adelaide? Have you been to Adelaide before? And is there something that maybe you'd like to do outside of the Congress, taking advantage of the Adelaide area?
Well, I've been to Australia quite a few times before, but never to Adelaide. So I'm really looking forward to it. And what I always do when I visit somewhere is I ask locals for recommendations for what to do. So I'm open to suggestions. I always in cities. I always love to walk around cities, use public transport. It gives you a good sense of what's going on. And so I always enjoy visiting new places, and I will certainly make time to get to know Adelaide as well as to enjoy the amazing science. And I think the thing about the Congress is that it is this intersection between the two disciplines that I love, which is medical physics and biomedical engineering. And so the opportunity to get that in one place is really exciting.
No, it is. And we'll have to get you on the tram down to Glenelg and maybe out to Kangaroo Island. It's probably a bit far to be going up to the Flinders Ranges, but if you like some wine, we'll get you up to the wine country of
Sounds wonderful. Sounds wonderful.
I have a guest interviewer now to introduce, and you may know this person, Simon. Hugo Currie's a student studying physics and engineering at ANU. We're here in Australia, and he's submitted an abstract at the World Congress, which has been accepted. I think it's important to consider the student perspective, especially with what you've just been talking about these exciting things for the future and being able to harness that next generation. So over to you, Hugo.
Thanks, Geoff, and thanks, Simon, and thanks for the opportunity to ask a few questions. So my first question is, how does your work contribute to shaping the future of medical physics, biomedical engineering, or healthcare innovation?
Yeah, that's a really good question. So we have a number of goals in our research. So, the first one is we want to improve diagnostic medicine. And in my case, we're trying to do that through technological innovation. And so that's one important thing. But we've also got our mind very much on research because, the research of today will be the clinical applications of tomorrow, we hope. And so we're also trying to provide very high-end, cutting-edge tools that researchers can use to really study and understand how the human body works together as a system. And then I also want to comment that although we work on this high-end technology, which tends to be pretty expensive as well, we're certainly aware and very interested in the challenge of how we make this technology more accessible on a global scale. And I think that's really important that we're always thinking about that. And certainly I hope it's something I will attempt to address in my presentation at the Congress.
Awesome. So do you have any thoughts on why physics and engineering students should attend this Congress?
Absolutely. You guys are the future. So it's really important that we have a lot of students there to see what's going on and to get them engaged and interested. So for me, as I already mentioned, this is an exciting Congress because it brings together two very closely related disciplines, medical physics and also biomedical engineering. And so we're going to see through all the presentations of this Congress how physics and engineering influence medicine. And the other thing that's really great about this Congress compared to many other conferences is it has a truly global focus. So we get to see the challenges and needs around the world for new technologies that can address global issues. And so I think it's a great place for students to get a feel for what's going on, what the opportunities are, and where the needs are.
Thank you very much.
Well, thanks, Hugo, and enormous thanks to Professor Cherry for taking the time to give us his insights. He's very busy, and we do look forward to seeing you here in Australia, in Adelaide, in a few months' time. And here when we go.
Yeah, I'm looking forward to much and to seeing both of you and everybody else at the Congress.
No problem. Thanks very much for your time.
Thank you. Thanks.